All right, so Unit 8, Section 11, washer method, revolve around the X or Y axis. So it's very similar to what we were doing yesterday, okay? The difference here is we now have two functions in which we are going to revolve around an axis. So if we copy this function out, so we're going to basically copy this. Stop moving. So copy this area right here down below the x-axis. So we have something along the lines of that. Again, doesn't have to be perfect. Okay. Now, the issue is if we do revolve this around the x-axis, okay, so we have this shape here, again, we have this little shapes and the big one. We do revolve this. What would the cross section look like? If we cut out a cross section, what would it look like? And the key is, what's the name of this method? Okay. We'd have a big circle, and then in here, we would have a little circle, where we're finding the area of just this outer part. Okay, so yeah, I mean, you could call it the donut method if you want, but they went more technical term in the washer method, because it looks kind of like a washer. Okay, so just to give you a better idea of what this looks like, I did find another one of these graphs, and it's going to do that again because, oh, good, it didn't. So here we have our function, and if we rotate it around the x-axis, right, we get this shape here, which is, again, a little hard to tell, but it is, again, kind of like a bell. Right? So yeah, there it is. I like this thing. All right. So that's the idea. That's what we're going to do. And it's really not too bad. It's very similar to what we talked about before. We have now, in this case, a outer radius and an inner radius. Okay. We are going to find basically the volume or the area of this whole shape. Okay. And then we're going to subtract out the area of that middle part. Okay. So in this case, what is my outer radius? Radius. Basically, which of these functions is further from the x-axis? So it would be this one here, square root of x. All right, so this is my outer radius. Now, usually we label the outer radius as that capital R of x. Okay. All right, and then we have an inner radius. Which we label as a lowercase r of x. So the idea here is if I'm going to basically find the volume of these two shapes separately and then subtract them. So I would have volume is equal to, they're going from 0 to 1 here on the x. So 0 to 1, pi of my outer radius, okay, which was the square root of x squared dx, minus the integral from 0 to 1 of pi of my inner radius, x squared dx. Now, because these have the same bounds, this is the same integral, we can combine this into one integral. We can rewrite this as volume is equal to, I'm going to put pi outside, they both have pi, from 0 to 1 of my outer radius squared minus my inner radius squared dx. And that's really what we're trying to get to. Okay. So I'm not going to worry about finding the actual, because you guys can just put this on a calculator. on these questions on the test, it's not going to be like the other ones where I'm trying to find some simple volume where you only have one function. Okay, here with all these multiple functions, I'd probably just give you guys the calculator. These are the calculator version. So our concept here is that we have the integral from a to b of pi times the capital R of x squared minus, or dx, minus the integral from a to b of the lowercase r of x squared dx. Oh, don't forget pi. Never forget pi. That's something people do often, is they forget pi. These are all going to be circles, so yeah, you got to have pi. So this is going to become what we just did when we combined these, the outer radius squared minus the inner radius squared dx into one integral. All right, where capital R of x, like we said, is the outside, and lowercase r of x is the inside. Now, the reason why we kind of focused on setting this up, and I forgot the minus sign here. Sorry, minus sign. The reason why we focus on setting these up separately is because one of the most common mistakes people make is to write it like this, which is the r of x squared, r of x minus lowercase r of x squared. This is not the same thing as r of x squared minus lowercase r of x squared. Okay, so yeah, do not do this. Okay, don't do that, please. Make sure you know you're squaring those separately. The idea is you're finding one volume and subtracting the other volume, or one area and subtracting the other area and finding the volume of that. All right, we're good. So we are going to rotate this around the y-axis. So let's we have the graph of the y part done. Or the x squared plus 1 done. Let's mirror this over. Okay, so we are revolving this area right here. Again, it creates that nice little bell almost. So as we rotate. All right. Now, if we're rotating around the y-axis, what must our function be in terms of? Yeah, it needs to be in terms of y. So here, for the first one, if we subtract 1 over, we get y minus 1 equals x squared. So x equals plus or minus square root of y minus 1. Now, since we are revolving only this side of the function, I'm not going to worry about the negative, just the positive. If I was revolving the other side of the function around, then yes, I would worry about the negative and not worry about the positive. Right, so here, subtract 1, y minus 1 equals 2x. So x is equal to y minus 1 over 2. There's our two functions. So this would be my outer, my capital R of x. This would be my inner, well, r of y technically. So lowercase r of y. So integrate from 0 to 1. We'll go ahead and put the pi outside. Okay. My outer radius, which is the square root of y minus 1 squared minus the inner radius, y minus 1 over 2 squared dy. And again, you guys can put this in a calculator. I'm not going to worry about actually finding the value of this. I just want to make sure we know how to set things up.
0 to 1 and 0 to 5.
Oh, 0 to 5. You're correct. Thank you. So yeah, 0 to 5. And not even 0 to 5, is it? I got the previous integral. What is it? What does it start at? It starts at 1. 1 to 5. I'm just making sure you're paying attention. That's all. That's what we always say, right? All right. Any questions on this? Because that's it for this first part. This is going to be very similar to basically almost like a mirror image of what we did yesterday. Where we revolve around the axis and then we revolve around other than an axis. Okay. The difference here is we have that outer radius and inner radius. That is the only difference. So we are going to treat the second part very similar. I'm going to show you two ways to do this. Now, this time though, I'm going to show you both ways together instead of doing one way and then going back and showing, oh, hey, you could do this a separate way. All right. So again, if we remember what we did yesterday, we kind of came up with that concept that my radius, okay, if you're revolving around something other than an axis, okay, my radius is whatever is furthest from the axis minus closest to the axis. Okay. So is your line of revolution closer or furthest from the x-axis? If it's further from your x-axis, that goes first. Whatever is furthest, whether it is your function or the line you're revolving around, whichever is furthest from the x-axis goes first. Then you subtract what is closest to the x-axis. Okay? And again, I'll give you hopefully give you kind of a visual representation of this in just a moment. But again, we're going to take that concept of this is going to be that outer radius still. We're still going to be doing that minus the inner radius. Okay? dx. So, here, we are going to be revolving this around the line y equals 2. So I'm going to do a little dash line around y equals 2. So, in this case, my radius, since the line of revolution, the y equals 2, is furthest from the x-axis, that is going to go first. Is what I'm going to do is I'm going to find this total area, or this total distance, and then I'm going to take off this distance. Now this distance right here, for that outer radius, is x squared. Okay. This distance right here is 2. So if I want just this part, well, that has to be 2 minus x squared. So that's what we mean. Whatever's furthest from the axis goes first. That gives us my radius. Now, that is just for the outer radius. So if I want the inner radius, I'm still going to take that distance to the x-axis. This time, my inner part here is the square root of x. So this part becomes 2 minus square root of x. So that is my inner radius. So we are going to do v is equal to pi integral from 0 to 1 here. 0 to 1, 1 to 1 there. Okay. Now again, my outer radius we said was 2 minus x squared. Again, still got to square that. Minus my inner radius was 2 minus square root of x. Got to square that. dx. Okay. Now, honestly, I don't think if you get that wrapped around your head that it's always going to be what's furthest from the x-axis minus what's closer to the x-axis is your radius, it's really not that bad. But there's, again, like we said, sometimes, again, it depends on how you view things. It might be easier to do what we did yesterday, which is just to shift everything down, shift my line of rotation down to the x-axis, which means everything's going to shift down too. So I'm going to take my functions, y equals square root of x, and if I shift down 2, that gives me y equals square root of x minus 2. If I take y equals x squared, and again, shift down 2, y equals x squared minus 2. So now it's going to be exactly what we did just a few moments ago. Copy on that. So now volume is equal to pi integral from 0 to 1 still of my outer radius, okay, which is that x squared minus 2, okay, squared, don't forget squared, and then square root of x minus 2 squared dx, okay? And again, like we said, because we're squaring it, does it really matter if it's x squared minus 2 or 2 squared minus x? No. Or 2 minus x squared, sorry. So no, it doesn't matter. They're both equivalent. So again, whichever one you're most comfortable with, whatever one just makes the most amount of sense to you, do it that way. Okay? I will not grade you on, you have to do it this way. No. Pick your favorite way and do it that way. That's why I'm showing you two different ways. All right. So here we are revolving this around the the line x equals -1, which is this line here. Okay. Now this makes it really fun to actually draw that line. All right, and we have, there we go. We have this rotation on this rotation. Don't really need that part right there. So there we go. That's what we're going to rotate around, is this area being rotated around. Now, what's the problem I have at the very beginning? Rotating around a vertical line, which means I'm rotating kind of like I would around the y-axis. And if I'm rotating something around a y-axis, what must my function be in terms of? Yeah, we need to solve for y again. So, or solve for x again. So here we're going to subtract 1, minus 1. We get x is equal to, again, plus or minus square root of y minus 1. But again, I'm only going to be dealing with the positive side, so don't worry about the negative. Here, subtract 1, subtract 1. Again, we get that same kind of function we had before. It is the same function, isn't it? Yeah. So x is equal to y minus 1 over 2. So they're my two functions. Now, in this case, this one's a bit odd, because when I say which one's furthest from the y-axis, okay, because my line of rotation is below the y-axis and my function is below, to the left of the y-axis, and my functions are to the right of the y-axis, basically I'm kind of saying which one's to the most right of the y-axis. Okay, so in this case, what is more right to the y-axis? Well, that would be the functions themselves. So I'm going to take the two functions, volume is equal to pi integral from 1 to 5, because I'm going to get that right this time, of my outer function, which is that square root function, which changed into this one, square root of y minus 1 minus my line of rotation. Now, what happens when you minus a -1? You get a positive 1. Okay. Minus, again, my inner function, y minus 1 over 2, again, minus a -1 squared, which becomes plus 1, dy. Or shift where? Shift right one. Now, what is shifting right one going to do? That's going to add one to all my functions. Because, again, now because they are in terms of y, it is like shifting up in terms of x. So my new function, x equals square root of y minus 1 plus 1. X equals y minus 1 over 2 plus 1. Which in this case, it happens to be the exact same radius we had before. Y minus 1 squared plus 1 squared minus, oh, don't need that. Y minus 1 over 2 plus 1 squared dy. And that is it. That is it. That is how we set these up. Now, this homework, because this is the end of Calc 1, and the end of our lesson, the homework will have a good set of review questions of what was covered in Chapter 8. So it's going to have just some basic area question, area between curves questions, rotating one line, cross-section questions. It's going to give you a bunch of different questions, so you're not going to just do this. You're going to do a kind of a mixed review here. And the idea of that is you need to be able to decide what method to use when. Any questions? Well, that is it. It's our last lesson of the semester.